Currently, the average in-city combined water and sewer bill for a household in Atlanta is $107 per month. When we get to the next rate increase, July 1st of this year, since 2004, we will have tripled the water and sewer rates in the city of Atlanta to pay for these programs. We also have a dedicated 1-cent sales tax that goes to water and sewer infrastructure development. And as far as I know, we are the only city in the United States that has that sales tax. So it's an expensive program, but we're able to do a lot of things. Here's some statistics in terms of the size of the water system. We're actually, on the drinking water side, a regional system, almost 4,000 kilometers of pipe. Some of it's over 100 years old. You get a lot of leakage, a lot of repair that has to go on. We also wholesale water, about 1,700 square kilometers of service area. And on the wastewater side, we're also regional. If you notice the shaded areas, they don't match. So we cover a pretty large area. Again, almost 2,600 kilometers of pipe. And you can see the rest of the statistics. We serve, in both cases, about 1.2 million people on a daily basis. In 2000, we had about 1,000 sewer spills. We're under 2 federal consent decrees in terms of addressing that, and we've completed the first one. One of the consent decree orders, just in terms of some of the projects we're involved with, we've completed all 9 construction projects. On the combined sewer, we have a combined sewer, which Montreal had at one time also, for the downtown area. We just separated parts of that combined sewer. We spent $300 million separating the sewer. We completed that over the summer. Those areas have new sewer pipes, new drinking water pipes, and then we went in and paved the streets. So some amount of satisfaction out of the incredible pain of having their entire street torn up for months on end. We also completed, the photograph here is of a tunnel boring machine. Atlanta sits on solid granite bedrock, and we constructed 2 8-mile tunnels, one of which the finished diameter is 27 feet diameter. So these are very large projects. We completed that in November, but part of the capital program we're in, I mentioned the separated sewer, or the part of our system that is not combined sewer is already separated, and we're working through some detailed schedules and projects of going in and evaluating every linear foot of that sewer through closed circuit TV analysis, evaluating that. Some of it's fine, some of it goes into a sewer rehab project. We're using a number of different techniques, pipe bursting, lining, other activities there, and then sewer capacity, new projects of building new sewers throughout some of the area. We also have, on the drinking water side, major capital projects, water main replacement projects, as well as repair projects in terms of lining. We have right now about $326 million of new water mains that are in design that we're getting ready to go into construction with. We're coming to the end of a automated meter reading program where we're replacing all of the small meters in our system, about 150,000 small meters, with an AMR process to drive-by read. And we're also have a problem, or a program, on our large meters, about 2,000 large meters that we're either repairing or replacing. And we have an extensive leak repair program that's going on. I'm not going to go through it today, but I have with me our current capital plan list that is about 100 projects or programs over the next 10 years. And the burn rate of our investment in capital is $300 to $500 million a year. So there's lots of business opportunities. We look forward to people coming in with new ideas and projects, and certainly to bid on those projects. Sewer spills, which is the photograph there. We've reduced the volume of sewer spills by about 80% over the last 4 or 5 years. And in terms of the leaks we're doing now, the drinking water system for about 4 years, was privatized. We took that back in 2004. When it was privatized, the vendor was only doing about 750 leak repairs a year to the system. We're doing about 800 per month. And that translates to about 54 million gallons of water per year saved just from that leak repair. And from a sustainability aspect, not only managing water resources, but water has a direct translation to energy requirements. You saw a graph, this information in a graph that Lou's presented. This is the Atlanta greenhouse gas inventory. And the blue area, appropriately, is water and wastewater. 27% of our greenhouse gas, the 540,000 metric tons, is from electric demand for water and wastewater. Well, why is that? Well, what do you do in water and wastewater systems? You take water from someplace, you pump it, you treat it, which only really involves people, energy, and chemicals. You pump it someplace so they can use it, you collect it, you pump it into a wastewater treatment plant, use a lot of energy to treat it, and then in Atlanta we put it back into the river. So electricity in terms of our footprint is a huge component. We have some natural gas that comes in there at 5%, but the real focus, bang for your buck, is if you can improve your energy efficiency, you can grossly change your carbon footprint. And in particular, in Georgia, our energy supply is largely from coal-fired power plants. And you can see here in Georgia, it's 70% coal, and a very high emission factor out of those coal-fired plants. So in some comparisons with cities, we may be using on the utility side the same amount of water as a comparable utility in Boston, for example. Same amount of energy. But the fact is because we have such a high percentage of coal, we have a much larger carbon footprint. What can you do about the amount of energy you use, and what, if anything, can you do about the source of that power? So reducing energy consumption, some of the activities that go on, looking at process optimization. Part of a biological treatment system for wastewater involves a lot of aeration, where you're using blowers to blow air in to get the oxygen level up in the waste stream. Well, you need to look at how well that treatment is working. If you're blowing more air in than necessary, you're not getting any better treatment efficiency, but you sure are driving up your energy cost excuse me, and the amount of energy you use. So part of what we're doing throughout our facilities is looking at process optimization. How do you get the best treatment with the lowest energy use? And another thing we're doing is going through the system and looking at the blowers and pumps. We have about $5 million right now going out and changing out to more efficient pumps in our system, looking at how we reduce energy consumption and reduce our carbon footprint. You can also look at how you change your energy supply. In this case, we have a couple different projects going. Atlanta is not a very windy city, but one of the advantages we have on our water side is you tend to place water plants, water facilities at high elevations, because then you can use that head as part of the pressure in your system. So back in about 1880, the city fathers at the time, and they were fathers at the time, outside of Atlanta, purchased the plant that's shown here on the left, that property, which is the Hemphill Reservoir. And that's a beautiful view of Atlanta's skyline because it is the highest elevation in the city. So we're looking at a wind turbine project at that site. It's high, it's relatively open. You can see the edge of one of our two reservoirs at the site. It's an opportunity that we have enough wind in that area that we're experimenting on a project with a wind turbine to try to move some of the energy for the process away from the coal-fired plant to a more sustainable energy source.